Okay, here we go. Today, short lesson on how to make a graph when all you have to work with is a linear equation. So, when you're done with this video, hopefully you'll be able to see something like this and do that. This is one of the Common Core 8th grade standards for functions, multiple representations of functions. We've been working on going between tables, XY tables, to graphs, to tile patterns, where you have the little squares, and what else have we been doing? Equations. Okay, so this covers part of that. Okay, today we're covering graphs, equations, going from there to there. Lots of different connections to make. Today we're just going to focus on one. Here's how you do it. Let's take our example equation from up above. Okay. 2x plus 3. You know that the 2 represents the rate of change. Later on in algebra, you're going to recognize this as the slope, which is calculated as the change in y over the change in x, or how much does y go up or down every time x goes to the right. Okay, how much does y go down every time x goes one to the right? And the 3 represents the initial value. Later on, the lingo will be the y-intercept, which becomes key in this strategy of how to change it into a graph. Okay, and that's just where do you put a dot on the y-axis? On the y-axis, very simply stated. So, you get out the ruler, make a y-axis, make an x-axis, x is horizontal, y is vertical. You already knew that. First, we're going to start with the initial value. Does that make sense? Because initial means start also. The y-intercept, where do you put a dot on the y-axis? Right here, positive 3. 1, 2, 3. Make a dot. Step 2, so this is step 1. And step 2, in this case, is the 2. What is the rate of change? In other words, how much does y go up or down each time I go across 1x? The answer is 2. It goes up 1, right, because it's positive. We don't see a positive sign there, but 2 means positive 2. So from this point, x goes over 1, y goes up 2. You can see I'm going to run out of room here. I didn't plan very well. X goes over another one, y goes up 2. Get the ruler out, connect the dots. Good thing I used red. That's it. That's how you do this. Short and sweet, 2 steps. As long as you know the vocabulary, so easy. Let's do one other one just to teach you. Sometimes you will have a fraction. Just when you get used to doing it, someone will throw a fraction at you, and all of a sudden it might seem like it's a different type of problem, that it's a hard problem now or whatever. But if you know what you're doing, and you trust yourself that you're doing it the right way, it's no different than the one we just did, because you ask the same questions and you do everything in the same order. So, I ask you, remember, step 1 is over here. What's the y-intercept, right? What's the initial value? IV for initial value. It's 3, positive 3. So I put a dot on 3, right? 1, 2, 3 on the y-axis. Then the second question you ask, how much does y go up or down for each x? And the simple answer here is, well, y goes up 1/2 for each x that goes by. The problem is with most graphs, the intervals are whole numbers. And we don't like to estimate when we're making a graph. We like it to be precise. So how can we make a precise graph with a fraction? And the answer is simply this. We kind of split this up. Or this is how I do it. You can do it however you want to. But if you split this up and match up the y with the numerator and the x with the denominator, then you have this situation. So we can see that y, since it's a positive number, y goes up 1 for every 2 x's. So y is going to go up 1, but it's going to take 2 x's to get there. That's how a fraction works on a graph. Okay? So, starting from the y-intercept, I just read this across like the mark of Zorro, right? Like a Z. I read it as a sentence. Y goes up 1 for every 2 x's. Y goes up 1 for every 2 x's. And I keep saying it every time to make a dot. Y goes up 1 to make, but it takes 2 x's to get there. That's how you do a fraction. And that is that. Okay. Now, just some little facts, fun facts that you should know. This will help you make predictions. Like right away, when you see an equation, you should be able to predict about what that graph is going to look like. Let me show you what I mean. If I just make a straight line at a 45-degree angle here, right? That's the y equals x line. Now, if I have a fraction that's less than 1, right, such as 1/2, 2/3, 3/11, any kind of fraction that's less than 1, the graph is going to go down here. Okay? Any kind of number, including fractions, including improper fractions, but if it's greater than 1, it's going to go up here. And the greater than 1 it gets, the steeper it's going to get. I can make a separate video on this alone. But if you can just put in your head that, for example, if y equals 9x plus something, you could predict that that is going to be a very steep line going up. If you had something like y equals negative 1/4 x, well, we know it's going to go down, but it's going to be very gradual because the fraction is very small, right? If it was y equals negative 2/3 x, it's still going to go down, but not as much as 1/4. Right? What if I had y equals 2x? Well, it's not going to go up this much. It's going to go up more than that, so it's probably going to go up right about there. Okay? So just some little fun facts. So you can predict what your graph will look like ahead of time. That way you can compare your actual graph to your prediction, and hopefully it's the same. And if not, it gives you somewhere to start. Let's do some practice. Go ahead, pause the video, write these problems down, do them, and then I'll come back in a second and show you all the answers, okay? Do not use a table. We're practicing not making a table here, so don't do that, all right? Thanks. Bye. Okay, we're back. Let's do this. The video is already 10 minutes long. I better hurry. We're going to go fast. First one, 3x plus 2. 2 is the y-intercept. 3 is the rate of change. That means y goes up 3 every time x goes by. Make a couple of dots. Get out the ruler. Connect the dots. There's your graph. That's how fast and easy this should be. Okay? Next one. 3 is the y-intercept. Again, not again, this time. And y goes up 1 for every 2 x's. So 2 x's go by, y goes up 1. 2 x's go by, y goes up 1. Y up because it's positive. If that was negative 1/2, I still would have had 2 x's go by because we always move to the right, but I would have gone down instead of up. But it was positive, up. Next, negative 5. 1, 2, 3, 4, 5 on the downside of the x-axis. Rate of change is positive. This line's going up, and it's going to be kind of steep. It's going up 2 for every x that goes by. Up 2 for each x that goes by. Remember, x always moves to the right. I know I already said that once, but I'm going to say it about 15 times. Make sure you get that. X always moves to the right. The only thing positive or negative is the y value that makes the line go up or down. Okay? Such as in this one here, negative 2. And this one means y goes down 2, but it takes 3 x's for that to happen. So here's how that works. Start at the y-intercept, take my 3 x's, 1, 2, 3, then I go down 2. Okay? And you kind of see I made a little triangle here. That's called a slope triangle. But that is another subject, another day, another video. Okay? Once again, x goes over 3, y goes down 2. That's what the equation tells me. It's so fun to make a graph without using a table. And I think it's kind of cool to do it without a graphing calculator too, to do it old school. Means you know what you're doing. Calculator only does what you tell it to do. Here we go. The y-intercept, there's nothing over here, so that means you put it at the origin, right? If there's nothing over there, it goes at the origin. Then from there, it's going to go up 4, 1, 2, 3, 4, for each x that goes by. So this is a very steep line, 1, 2, 3, 4. Dot goes right there. We can overcome poor planning by drawing a nice straight line. There's that. Is that what you got? I hope so. Next, here is the y-intercept, 4, 1, 2, 3, 4. But you notice there is no x over there, which means there's no change. Which means up or down? No. So use your common sense and you would know that that just means it's a flat line at 4. That's y equals 4. And here's one final one for you. This one you might have to pause and do separately. It couldn't fit on the screen the first time. Y equals 3/2 x plus 5. Maybe just work along with me here. Answer the question, where's the y-intercept, or the initial value? Yes, it's 5. 1, 2, 3, 4, 5. Starting there, what happens here? Y is going to go up 3 because it's positive, but it takes 2 x's to get there. Oh no, there's an announcement. 5202, call them now. Y goes up 3, 1, 2, 3, but it takes 2 x's for that to happen. Here's some more poor planning for you. Y goes up 3, 1, 2, 3, 2 x's, right? Y goes up 3, 2 x's. Dos X, 2 x's. Alright, there's all our graphs. I hope you had a good time. And you know what? Thank you for watching. I appreciate it, and mostly I just hope that it helps you. Please send me a comment and let me know if there's something else you want to learn. Okay? I'll do my best to put it up, and have a great day. Thanks a lot.